Okay, hey guys. Tonight let's talk about how to visualize the formation of a virtual image by a lens. If you're a lens designer, you already know this stuff. But if you're not a lens designer, I will try to explain as best as I can in both cases, whether you're a lens designer or not a lens designer. I hope you'll be patient with me because it's very hard to kind of mix together a dummied down version of the explanation as well as an advanced explanation. So we'll try to fix a balance between the two. All right. Okay. So there are many ways to talk about how to visualize the formation of virtual images. The way I'm going to do it tonight is to use this magnifying glass. And what I'm going to do is put the magnifying glass in front of my eye and then shift it closer to the webcam and then back. All right, like this. All right, so the first thing to notice is that when I put the magnifying glass just in front of my eye appears roughly the same size. But as I move it closer to the webcam, there's a point at which the eye gets bigger, and then when I put the magnifying glass in front of the webcam, it goes back to its roughly original size, right? And we can simulate all that. But what you have to understand is that what you're seeing through the magnifying glass is a virtual image of my eye. It's a magnified virtual image of my eye. All right. So we're going to get to that. Right. We're going to get to that. But interestingly, we can talk about all this by referring to the virtual image as being formed by the webcam and the webcam camera and the magnifying glass together in the following way, which is what I have on my screen right now. I've got a rough model of my magnifying glass, which I've estimated to be having a focal length of about 200 millimeters or so. I've estimated its radius of curvature and all its parameters. And I've set it up in such a way that on the left side of my screen here is the object, which is basically the distance from somewhere below my eye to my eye, which is the tip here. All right, that's around 35 millimeters or so, roughly, just roughly. And then on the right side here is a fictitious thin paraxial lens. Just think of that as an ideal lens, with a focal length of about 20 something millimeters. Okay. All right, and so what you're seeing here is that the web is a model of the situation where webcam is forming an image, a real image, right at the focal plane right here. So the distance from the axis to the tip here is the size of a real image of my eye area, which is this object here. It's a real image of the object from at this plane of the camera, and it will grow in size and reduce in size as I shift the magnifying glass from the object to the lens, which is webcam here. So I can animate that, right? Like this. Right? It's moving and moving. Okay, what you have to see is look at the plane here, this plane here. The distance from the axis to the tip gets bigger and then it gets smaller again. Right? It gets smaller again. Again, it's small, then it gets bigger, and then smaller again. That's going like this, that, and then back again like this, that, somewhere in the middle, and then like that. Okay. The other thing to notice is that, okay, if I zoom in here, you can see that as the magnifying glass is going closer to the webcam, the sharpness of focus gets worse, right? It gets defocused a bit. You can see the focal point is actually here now, and on the plane is some spot, right? And that's true because the webcam is a fixed focus lens. It doesn't have a focusing mechanism. So that's what it's simulating here. Okay, so now I've put the magnifying glass at the midpoint, which is where the maximum magnification was. So let's talk about virtual image and real images. What is going on really is that although at the focal plane of the webcam is a real image of the object, which is my eye area, what it is seeing is a virtual image of the object magnified as created by the magnifying glass. The magnifying glass creates a virtual image of the object that's bigger than the object as seen by the webcam. And then when the webcam captures its rays, the rays from the virtual image, it focuses the virtual image into a real image at this plane here. So how do we visualize that? Okay, so to do that, let's go to another screen. I have here another model, and I set up here first a configuration. We call it a configuration. Where I've got the object and my webcam lens and the focal plane, and it's not magnified. Now I'm going to add the magnifying glass. Now you can see it's magnified. It's bigger, right? About 1.8 something, 1.84 times magnifying power. Okay, so how do we visualize the virtual image? Okay, what I can do is I can tell the program to tell me where the virtual image is. Where is it located relative to the webcam lens? And I do it by clicking on third configuration, and there it is. Okay, what it's done is it's back tracing the rays. Let me go back to here. Okay, it's taking this ray and it's going, okay, you want to know where the virtual image is? I back trace the rays back here, and I back trace the rays back here, and they converge. They converge right here, roughly. Okay, roughly. And if I were to take the size of this, which is about 264 millimeters, and this 35 or so millimeters, if I were to divide that, is about 1.8 something. All right, that's what's happening. And you can see this virtual image is bigger than the object. And in fact, if you were to go back and review, the high school physics or high school optics, where they make you trace rays through lens diagrams and such, we can do this. If I take a line from the center here of the lens and connect it to the tip and trace backwards, this is what happens. There you go. I've got a line connecting from the center of the lens, a thin lens, that intersects the tip of my object and intersects ultimately at where the image is. Okay, I missed it by a little bit. I mean, I'm not perfect. Okay, so if you were to use, high school diagrams, ray trace, so-called first order thin lens diagrams, you will be doing this. You'll be back tracing a ray like this, and this other ray from the tip down this way and back that way, and intersect behind. So that's how you visualize the formation of a virtual image by a lens. All right, and I hope that's clear. Thank you. Bye-bye.